Hello everyone, I am Prabin. I'll be explaining about k-means clustering. So it comes under unsupervised learning. We can see that it is used to divide a dataset into k different groups or clusters, we can say, which do not overlap with each other. And each cluster is identified by a point called centroid, which is the mean of data points within the cluster. So our primary focus behind using this technique is to minimize the distance between two data points and their respective cluster center. So as you can see from the figure, before using the k-mean algorithm, data points are scattered, and after using the k-means, we have two different groups or clusters, we can say, and they are tightly bounded with each other. So to understand the algorithm, I divided the entire algorithm into 4 steps. So the first step is initialization. So in this step, we have to choose k number of clusters randomly, or we can say that we have to select k number of random points from the dataset as our initial center for the starting phase. For the second step, which is the assignment step, we have to assign each data point to a cluster, to a specific cluster whose centroid is closest to the data point. And after assigning this cluster, we'll be finding distance between the data point and our initial cluster point. This can be done by two methods. First is rectilinear distance measure, second is Euclidean distance measure. The third step is the updation step, where here we have to recalculate the centroids of the cluster. So what we'll be doing is we'll take the mean of all the distant points of data point assigned to each cluster, and that mean will be considered as new updated centroid. So the fourth step is repetition. So now with updated centroid, we have to repeat the assignment process and update the step until the centroids match, that is, they do not converge, or for a fixed number of iterations given in the question. So in this way, after completing all these 4 steps, we can see that the data points will be clustered and they will be categorized on some specific parameters. So in this way, k-means algorithm will help us to find the pattern, the unknown pattern within the data sets, and these patterns will be based on some specific characteristics that our data points share with each
So my name is Shivans Dave and my ID number is 22DC017. So today I will explain you about three of the distance measures used in ML for K-mean algorithms. So first off is Euclidean distance. So Euclidean distance calculates the distance between two real valued vectors. That means Euclidean distance are calculated when distance between two rows of data have numerical values such as floating point or integer values. So generally, the summation for Euclidean distance is this. That means square root of sum of 1 to n vi minus v2 whole square, where vi and v2 are the key points for the mapping. Also, Euclidean distance is also known as L2 vector form and is equivalent to the sum squared error and the root sum square error if square root is added. So this is one of the example of Euclidean distance. So it can be used in K-mean algorithms by using it with uh, accurate answer. Second is Manhattan distance. It is generally also known as L1 vector norm, and also it is also known as rectilinear distance. So the formula of Manhattan distance is sum for I to n sum mode of Vi minus V2, where Vi and V2 are the numerical points. This is one of the key example for Manhattan distance. Generally, Manhattan distance is used instead of Euclidean distance because of the easiness of Manhattan distance that is used for k-mean algorithms. It is perhaps more useful to vectors that describes object on uniform grid like chessboard or city box. It is also called taxi cab distance or city block distance. Also, the taxi cab name is for major reference to the institution of or what the measure calculates. That means the shortest path that a taxi cab would take between city blocks. In this, the city blocks are referred as the distance between the clusters. The third one is Minkowski distance. So this distance calculates the distance between two real valid vectors. Also, the formula is the distance measure is calculated as follows. So generally, it uses Euclidean distance, but it has 1 by p, where p is order parameter. So when p is set to 1, the calculation is same as Manhattan distance, but when p is set to 2, that it will become as same as the Euclidean distance. So intermediate values provide a control balance between the two measures. Generally, you can get a mode both of the distance measure in Minkowski distance. So it is commonly used when implementing a machine learning algorithm that uses distance measures, as it gives control over the type of distance measure used for real valued vectors via hyperparameter. Here it is denoted as p. Thank you.
Yeah. So hello everyone, my name is Japan Kacha and my ID is 22DC040. So today I'm going to discuss about the distance measurement. So there are the two types of that I will cover today. So first one is cosine, the second one is Hamming distances. So cosine has another two subtopics like cosine similarity and cosine distance. So first cosine similarity, that means the between two vectors there is some similar types of features, sentences or words that get in both of the section. So there is the formula of where a and b are the vectors of the can be derived using the Euclidean dot product formula. So yeah, that is the dot product formula, and there is a range of cosine similarity. So there are mainly three types of it: similar, unrelated, and opposite. So as you can see in the graph that similar has a lesser angle of the between two vectors, and unrelated have a wider angle, and opposite have a like almost the 180-degree type of the angle between the two vectors. So yeah, second one is cosine distance. So cosine distance is nothing but it if you minus the 1 minus cosine similarity, then you get the cosine distance. So range of cosine distance is from 0 to 2. 0 is identical vectors, then 1 is no correlation between the two vectors, and 2 is if you get the value of cosine distance is 2, then is absolute differently. So there is a reason why you should use cosine distance. So cosine distance get you that there is how they different both of the vectors from each other. So yeah, so now the second one is Hamming distance. So Hamming distance calculates the distance between two binary vectors, also referred to as binary strings or bit strings for short. You are more likely to going to encounter bit string when you one hot encode categorized columns of data. So here is an example of there are the three categories: red, green, and blue. So every categories contain only one bit in each the column. So yeah, if you get you want to measure the distance of between the two categories, then minus the red minus green. So whatever you get the difference, that is the Hamming distances. So that is the described in this formula that for every column you have to get the difference and then total it. Yeah. So thank you everyone.